We're going to start with the new unit, exponential and logarithmic functions, and we are doing lesson 8.1, which is on exploring the logarithmic function. So we are going to start with what is the inverse of the exponential function y equals a to the power of x. As you are familiar with the exponential function, a is the base and the independent variable x is the exponent. And the much simple way of trying to find the inverse of the exponential function is by switching the x and the y. But there is also another way to write the inverse of an exponential function, and that is by using what's called a logarithm or a logarithmic function. So we have here, if you have x is equal to a to the power of y, this statement can be written as y will also be equal to log of x to the base a. So both of these are equivalent statements. So let's say we have y equals log of x to the base a. We are going to look at what happens when we rewrite this relationship between y equals log x to the base a. It is equivalent to x equals a to the power of y, where x is what you have here. It becomes the answer here. This becomes the base here, and the y becomes the exponent here. So it is very important that you recognize how to rewrite y equals log x to the base a as x is equal to a to the power of y, because they both mean the same thing and they're just different ways of writing the same relationship. One is in the form of just exponents and the other is in the form of logarithms. We're going to look now at a couple of examples that will help us to kind of understand the relationships. So let's say we have y equals 5 to the power of x. Our question is to write the equation of the inverse of each in exponential form and logarithmic form. So we can write the inverse of this relationship or this function, which is an exponential form, in its exponential form as well as in its logarithmic form. So there's two ways to write the inverse of this function. So the inverse of what's given can be written by just switching the x and the y. So if you just switch the x and the y, this will be x equals 5 to the power of y. And this is the same as the relationship y equals log of x to the base 5. Okay, so these are equivalent relationships, this and this. Okay, similarly, if you wanted to find the inverse of y equals 1 over 10 to the power of x, you have two ways of writing the inverse of this function. One is by just switching the x and the y. X is equal to 1 over 10 to the power of y. Or another equivalent way using logarithms is to say that this y is equal to log of x to the base 1 over 10. Okay, so these two are the same expressions in different formats. Let's look now at two more examples here where we have to find the equation of each logarithmic in exponential form, then write the equation of the inverse. So I have a relationship here that says y equals log of x to the base 5. Typically, when you write this relationship, it is y equals, just remember that it's log of x and the base is written right here at the bottom. Don't write it up here because it will look like 5 times x, but it's not 5 times x, it's log of x to the base 5. So I want to write this in its exponential form. So what is the exponential equivalent of this logarithmic function? The exponential equivalent is going to be x equals 5 to the power of y. Okay, and you know that x equals 5 to the power of y is the same as y equals log of x to the base 5. Okay, and then write the equation of the inverse. So what would so these two are the same. Okay, this is all the same. These are all same. But what does the inverse equation look like? The inverse equation of this would be, you can take this and write its inverse, which would be y equals 5 to the power of x. Okay, so that would be the equation of the inverse. Let's find the equivalent exponential form of this relationship. The equivalent exponential form of y equals log of x to the base 2 or 5 is in exponential form, x equals log, x equals, this is an exponential form, x equals 2 over 5 to the power of y. Okay, and what is the inverse of either of these forms? Well, we're just going to switch the y and the x. Y equals 2 over 5 to the power of x. Okay, so when I put these arrows like this, it means they both mean the same thing, but this is not the same as these because this is the inverse of these. We're going to now look at an example where we have to evaluate. I'm just going to take off this and start fresh. What would be the answer of log of 25 to the base 5? We can get these answers by trying to evaluate them. So we will say, well, let y be log of 25 to the base 5. That's our answer. And we think about the other way in which to write this. What is the other way to write y equals log of 25 to the base 5? The other way to write this is 25 is equal to 5 to the power of y. So this is the logarithmic way to write this statement, and this is the exponential way to write the same statement. They both mean the same thing. So I'm replacing this with 25 is equal to 5 to the power of y. And now I can easily say that 25 is equal to 5 squared. So therefore I know that y is equal to 2. So I have the answer here without using a calculator. I'm just using the exponential way of writing this expression to evaluate. So similarly, if I want to find what is log of 27 to the base 3, let's say y is equal to log of 27 to the base 3. The equivalent way to write this expression in its exponential form is to say 27 is equal to 3 to the power of y. And then we can, well, we know that 27 is 3 cubed, right? 3 cubed is 3 to the power of y. So we can clearly see that 3 equals y, or y equals 3. Okay? And even here, I didn't write this, I could have just gone from here and written, instead of 25, I wrote 5 squared is equal to 5 to the power of y. And you can clearly see that since the bases are both 5, that means y is equal to 2. Okay, so you can write it like that too. So we have an example where we have to sketch the graph of y equals 2 to the power of x on the grid that's provided. We also are going to state the domain and range. And we're going to sketch the graph of the inverse of this given function on the same grid. So our given function is the parent function for exponential functions, which is y is equal to 2 to the power of x. In order to graph this function, we need some points. We know that the x-intercept is the value of x when y is equal to 0. So if you put 2 to the power of 0, we would find, if we want, let's start it this way. We put y is equal to 0. And, sorry, not the x-intercept. I'm talking about the y-intercept, the x-intercept. Let's say we want to find the y-intercept. We're going to put x equals to 0, and we get y would be equal to 2 to the power of 0, y will be equal to the 1. So our y-intercept would be 0, 1, those points. And we also know that for this exponential function, there's a horizontal asymptote, which has the equation y equals 0, which is the equation of the x-axis. So these are some features about this function that we already know, which we can use when we're trying to sketch the graph of this function. We can also draw a table of values to kind of get some points for this function. So let's do that. Let's give values to x. Let's go from -2 to +2. The y value here would be 2 to the power of -2, which is 0.25, 2 to the power of -1, which is 0.5, 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, 2 to the power of 2, which is 4. So we have some points here. And then we can use those points to graph the sketch of the parent function. So let's go ahead and do that. -2 and 0.25, -1 and 0.5, 0 and 1, 1 and 2, 2 and 4. And so you can see that if we join these points with a smooth curve, we get the graph of y equals 2 to the power of x. And we can see it's approaching the x-axis, but it'll never meet it. So this is the equation of the horizontal asymptote, which is y equals 0. And we can see that the point we have here, which is the y-intercept, is 0, 1, which we have right here. Okay, so all the key features of that function are there. Then we are going to plot the graph of the inverse. So to find the graph of the inverse, we can just, the inverse function would be the function that you get from just switching the x and the y. So it'll be x equals 2 to the power of y. Or we can write this in its logarithmic form, which is y is equal to log of x to the base 2. Okay. And the easiest way to now get the table of values for this function is to take the points that we got from the original function and just switch the x and the y values. And that will be giving us points for the inverse function. So this will be 0.25 and -2, 0.5 and -1, 1 and 0, 2 and 1, and 4 and 2. And we can just now plot these points on this graph. So 0.25 and -2. So 0.25 is somewhere here, -2 is right here. Half and -1, so somewhere here. 1 and 0, which is right here. 2 and 1, which is right here. And then 4 and 2, which is right here. I'm just going to connect those and draw a smooth curve. So this is kind of where my function inverses, which is, I can write it in either its logarithmic form or its exponential form. Its exponential form, it's x equals 2 to the power of y. Or I could write in its logarithmic form, which is y equals, which is the more preferred form because it's written y equals log of x to the base 2. Okay. And for a function and its inverse, the axis of symmetry is the line which is y equals x. So I can just draw that here just to show you. So the y equals x would be when x is 0, y is 0, when x is 1, y is 1, x is 2, y is 2. So these are the points for the equation of the line y equals x. So if you took a ruler and we drew a line here, this line here would be the axis of symmetry. Y equals x would be the axis of symmetry for this given function y equals 2 to the power of x, and its inverse function, which is y equals log of x to the base of 2. Okay. I also added to do the domain and range for the parent function. If you look at the domain, it is x can be any real number, and the range has a restriction. Y is a real number, but you cannot have any y values that go below 0. So y is always positive or y is greater than 0. And if you looked at the inverse function from the graph, we can see that the domain is x is a real number, such that you can see there's a restriction on the x because You can't get any values of x that are negative. They're only going to be over 0, so x greater than 0. And the range is that y is a real number. Okay, so there you have how to graph a function and its inverse if you're given a exponential function, and the key features. Now you can work on the homework